Hello everybody. Today I would like to talk about the effect of co-digestion of organic fraction municipal solid waste with waste activated sludge on biohydrogen production under dry anaerobic digestion condition. The authors are Mohammed Samadoni, PhD student in Environmental Engineering Department at Egypt Japan University of Science and Technology, Professor Ahmed Tawfiq, Professor in Environmental Engineering Department at Egypt Japan University of Science and Technology. About the presenter, my name is Mohammed Mahmoud Samadouni and I am a civil engineer working as assistant lecturer in Public Works Department, Faculty of Engineering, Tanta University. And now I am in a scholarship to finish my PhD degree at Environmental Engineering Department, Egypt Japan University for Science and Technology, funded by Egyptian Ministry of Higher Education. And my study field in PhD is organic solid waste treatment. And this is my contact information. This research aims to solve problems associated with our society here in Egypt, such as municipal solid waste and depletion of fossil fuel energy sources. And this photo shows how big of these problems, which we face daily. And the scope of this study is to try to find a solution to such problems. Total amount of municipal solid waste generated in Egypt estimated to be about 21 million tons annually, and the organic content represents about 50 to 60%. Most of this municipal solid waste thrown in dam site in desert to burn and covered by sand. Also, there is some locations of landfills, such as here in Alexandria. There is Borg Al Arab landfill and El Hammam landfill. But there is some problem associated with landfill, such as odor emanation and vermin attraction, toxic gas emission, and groundwater contamination. So we choose to treat municipal solid waste with anaerobic digestion, which is more attractive due to low energy consumption, cost effective, and can deal with several types of substrate for the production of hydrogen or methane, and eco-friendly. The following flowchart will illustrate the degradation mechanism of organic matter through anaerobic digestion, which passes through four main processes: hydrolysis, fermentation, acidogenesis, and finally methanogenesis. Hydrolysis is considered the rate limiting step, as most of complex organic matter converted to more easily degradable substance. As we see in this chart, methane is the final product, but also there is some intermediate products such as volatile fatty acids and hydrogen. Hydrogen and methane are the two main gaseous energy carriers, but I choose to produce hydrogen instead of methane because it has high energy yield of 122 kJ per gram hydrogen, and it's a clean fuel as it produces zero carbon dioxide emission. Hydrogen can be produced instead of methane in anaerobic digestion by adjusting the process parameter to inactive hydrogen consuming microorganism. Thus, the hydrogen and volatile fatty acid will be the final product. So we have the problem, which is organic fraction of municipal solid waste. Through anaerobic digestion, we can achieve three main targets. The first one is the reduction of organic fraction of municipal solid waste. The second one is energy production in terms of hydrogen and methane, and finally generation of organic fertilizer. The objectives of this study can be summarized to evaluation the effect of a changing co-digestion ratio on hydrogen production and substrate fermentation process, of organic fraction of municipal solid waste. Study the variation in volatile fatty acids production related to co-digestion ratio. In addition, study the effect of volatile solids content on hydrogen production and hydrogen yield. The materials used in this study are organic fraction of municipal solid waste, which contain mainly rice, vegetables, and meat, obtained from a restaurant on the campus of Egypt Japan University of Science and Technology. Before used in anaerobic digestion, it had been grinded by using a mechanical grinder into small pieces, then sieved in sieve number 9. Also, we used waste activated sludge obtained from Al-Agami wastewater treatment plant, which sited in Alexandria City. Before adding waste activated sludge, it has been sieved into sieve number 9 also. This table shows the characteristics of organic fraction municipal solid waste and waste activated sludge. Here we can see the total solid and percentage and volatile solid percentage for organic fraction municipal solid waste and waste activated sludge. Also we can see the COD and carbohydrate, protein and lipid for each one. The experiment was designed by changing volume between organic fraction municipal solid waste and the seeding sludge or waste activated sludge. This represents the volume percentage of organic fraction municipal solid waste, and this represents the volume percentage of waste activated sludge. And this is the different concentration taken in this study, as shown in the figure. The batch experiment was conducted in triplicate, and the operation temperature was 55 degree, which means thermophilic condition. The pH of the mixture was adjusted to be 5.5, and the working volume was 150 millimeter. And the waste activated sludge before used has been pre-treated by heat shock to 100 degree for 15 minutes. After filling the bottles with the different mixture, the headspace was flashed with nitrogen gas for a period of 1 minute to sustain an anaerobic environment in all batches, then capped tightly with rubber stopper and aluminum cap. The bottles were then placed in oven to maintain fixed temperature of 55 degree, which is thermophilic condition. The kinetic model used in this study is the modified converters equation. This is the equation where H is the cumulative hydrogen production at the reaction time T, and P is the hydrogen production potential. Rm is the maximum hydrogen production rate, and lambda is the lag phase. This table illustrates every reading in this study, such as gas volume, gas composition, and volatile fatty acids, and so on, and every method followed to gain this reading. For the result, this figure shows the effect of co-digestion ratio on cumulative hydrogen production. As shown in this figure, increasing organic fraction municipal solid waste percentage from 0 to 70% increase hydrogen production from approximately 100 to 524.2 millimeter. Further increase in organic fraction municipal solid waste percentage decrease hydrogen production. This table shows the correlations between the measured data and the simulated result obtained from converters equation. which shows significant correlation as R square is larger than 0.986. From this table, the maximum hydrogen production rate was 40.5, occurred at ratio of 70% organic fraction municipal solid waste to 30% waste activated sludge, with lag phase 7.5 hour. Also, the effect of a changing co-digestion ratio on substrate degradation was investigated. As shown in this figure, COD removal percentage decreased from 13 to 40%, with increasing organic fraction municipal solid waste percentage from 0 to 100. This may be due to increasing organic fraction municipal solid waste percentage increase the initial COD. However, the maximum COD removed from the batches was 1.55, achieved at co-digestion ratio of 70% of organic fraction municipal solid waste to 30% of waste activated sludge. Hydrogen yield was calculated by dividing the amount of hydrogen production per millimeter on gram COD removed. The maximum hydrogen production yield achieved at co-digestion ratio of 70 organic fraction municipal solid waste to 30% of waste activated sludge. In addition, the effect of volatile solids content on hydrogen production and hydrogen yield was studied. As shown in this figure, the maximum hydrogen production and maximum hydrogen yield achieved at volatile solids content of 22%. This corresponding to co-digestion ratio of 70% of organic fraction municipal solid waste to 30% of waste activated sludge. Volatile fatty acids is intermediate product combined with hydrogen production. As a result, maximum volatile fatty acids achieved at the same co-digestion ratio of 70% organic fraction municipal solid waste to 30% waste activated sludge. For the conclusions, the first one, maximum hydrogen production and maximum hydrogen yield were 524.2 mm and 338.4 mm per gram, achieved at optimum co-digestion ratio of 70% organic fraction municipal solid waste to 30% waste activated sludge. The second one, the volatile solids content has great impact on hydrogen production, and the proper percentage was 22%. The third, maximum volatile fatty acids were 9,043.5 gram per liter, achieved at co-digestion ratio of 70% organic fraction municipal solid waste to 30% waste activated sludge. Finally, the first author would like to thank Egyptian Ministry of Higher Education for providing him the financial support for his PhD scholarship, as well as the Egypt-Japan University of Science and Technology for offering the facility and tools needed to conduct this work. Thank you for your listening, and don't hesitate contacting me for any questions. Bye.